Hi friends, and welcome to this session on DI. Today we are going to do graphs, right? So this is our starting topic on DI, and before we even understand what is data interpretation and what data to interpret and how to interpret, I would like to tell you something about graphs. There can be one or two questions from this, and I have seen questions in past which are directly from graphs. So we have to understand firstly what are graphs. So the most important type of graphs from our exam point of view is line graphs, right? So line graph is generally drawn between two parameters. For example, you would see a graph of inflation, right? Rate of inflation versus various years, right? So in 2002 the inflation was something like this, then in 2003 it was this, and all that stuff. So in 2001, for example, it was 0.05, so its percentages, it was 5%, and then it increased to something more than 5%, then it went to 7%, and so on and so forth, right? So this is a typical line graph. You would see there is no trend as such, right? When I say trend, we cannot say that inflation is increasing each year or it is decreasing each year. Sometimes it is increasing and sometimes it is decreasing. So there are generally graphs in our macroeconomics are something like this, right? Where you cannot find trend usually, but there can be some parameters where there are trends as well. For example, if you see a graph between a repo rate and lending rate, it would be a direct proportionality graph, which means as repo rate increases, so the lending rate also increases. As there is a cut in repo rate, lending rate also decreases, right? So this is a direct proportionality graph. I'll show you a direct proportionality graph here, right? So I have plotted a distance traveled versus time, right? So this is a direct proportionality graph. After 1 hour he has covered 50, after 2 hours 100, after 3 hours 150, 4 hours 200, and after 5 hours it's 250. So the distance is directly increasing with time, which means what? Which means we can say distance is equal to k times time, where k is some constant, right? Or we can say k, which is a constant, is equal to d by t. And we know that this constant speed k is what? K is constant speed. So this guy must be traveling with constant speed, so that he travels how much? 250 kilometers in 5 hours, which means k here would be 50, right? So k is directly proportional to t. As time increases, distance also increases. Now if we want to plot here speed versus time, how do we do that? It has to be simple. We know that speed remains constant even with time. It is 50 kilometers per hour throughout. So the graph would be this. Speed versus time would be something like this. So here we are not interpreting right now anything out of graphs. We are just getting ourselves acquainted with various type of graphs. So this is a constant graph, a simple straight line parallel to x-axis, right? This is what is a speed versus time graph. Now if speed is increasing, let's say speed increases with time, and that too linearly, so a graph something like this would be there, right? So if there is a linear increase in speed, so graph would be something like this, right? So it means the speed is increasing. At 0 hours it was 0 kilometers per hour, at 1 hour it's 10, and all that stuff, right? So you would see that since the speed was increasing, it would reach 50 somewhere and then increase and keeps on increasing, and this increase in the speed is called acceleration, right? So we can say this is a constant acceleration graph, right? Because you can see if it's a perfect straight line, you would see that it's a direct proportionality graph. We can write some equation something which we have written before, something like speed is equal to k by t. Alright, k times t, because you see that as speed as time increases, speed also increases. So we can say s is equal to kt. So here k is what? K is nothing but acceleration, right? So this is direct proportionality, where two parameters are directly and linearly proportional, right? The important thing is linearly proportional. Now if we have a is equal to kb square, kb square means it's not linearly, it's now quadratically proportional. Again the proportionality is direct. So what do I mean by directly proportional to direct proportionality of two quantities? We have already seen that two quantities can be either directly proportional or inversely proportional. When they are directly proportional, it means increase in one would result in increase in the second as well. When they are inversely proportional, it means increase in one would result in decrease in another. So we'll see the inversely proportional thing as well. So here it's quadratic thing. The graph though is not seen as a smooth curve, it would be a smooth curve. It would be something like a U-shaped curve. We know that a quadratic equation is U-shaped, so it would be a U-shaped curve, right? So something like this. Here you see the increase is much larger, right? Suddenly at 15 it bumps up. So this is again a direct proportionality. Now I have drawn a linear proportionality and a quadratic proportionality. So at point 1 they both are equal. Now at point 2, while the direct proportionality would give us 2, the quadratic would give us something different, which is 2 square 4, let's say. The 3 would give us 3, and 3 square would give us 9, multiple of 9, right? So you would see the difference, this difference I'm talking about, this difference, the difference between the two lines, the distance between these two lines, they keep on increasing. So while this, if we extrapolate it, while this line keeps on going like this would go like this, right? So something like this. So you would see the distance keeps on increasing. So in our data interpretation questions, you have to be cognizant of the fact that which distance is increasing much faster, right? There can be questions which ask that which distance is increasing much faster. So for example, this is, let's say, this graph is our GDP growth, this is our inflation. So our inflation is increasing faster than our GDP growth, and we have to worry about it, right? So in that way we have to interpret various charts which we would see in future lectures, but now the main point is to acquaint you with various graphs. So this is direct proportionality, right? So there are questions which are there in your UPSC or in various exams where they ask what is direct proportionality, or they would draw a graph of direct proportionality and ask you what is it and what is meant by this graph, something like this, right? So this is direct proportionality. Now if there is, now look at this. So this parameter, this one, the blue line one, it started with a higher value, right? This parameter started with a lower value. The value was this one, this and this. But now you see, since the increase was higher, it crossed the value somewhere here and shooted it. So at, let's say at this year it was this much, whereas this was, we have to extrapolate it, this was this much. So firstly the difference was in this side, right? So this was the difference, and finally the difference becomes this. So if we consider this as positive difference, initially the difference was negative, right? It became 0 at one point, and then it becomes positive, right? So again, this would be a situation, this can be a situation where inflation was very high and GDP was very low to begin with, and then we did 1991 and our inflation suddenly decreases, or it keeps on increasing at a constant rate, but our GDP suddenly keeps on increasing at something which is not expected before, right? So GDP was shooting like anything, and then we have a positive difference. So something like this is direct proportionality. Again, the point here I'm trying to emphasize is direct proportionality can increase linearly, quadratically, or in any other proportion, so cubically or raised to power 4 or something like that. So as the power increases, this slope, so let's not use the word slope, so this the speed of increase increases, right? The speed with which the increase is happening also increases, right? So that's it about direct proportionality. Now what is inverse proportionality? Inversely proportional graph looks something like this. So at 1 it was 1, at 2 it became something like 0.5, at 3 it became something like 2.5 or something like that, at 4 it becomes 2.25, at 5 it becomes 2, at 6 it becomes 1.66 or something like that, right? So this is inverse proportionality. As the base value increases, or as the independent variable, so this is also called independent variable, this is called dependent variable, right? So as independent variable increases, the dependent variable decreases. The simplest way is a line graph, something like this, right? A straight line. At 1 it was 1, at 2 it has to be, let's say, 0.5 or 0.8, at 3 it has to be something like this, right? So this is inverse proportional relationship. So for example, if we have to travel 400 meters and our speed 400 kilometers and our speed varies, so as our speed increases, our time would decrease, which means s into t is equal to 400, which means if we are traveling at 400 kilometer per hour, we would take 1 hour. As we are traveling with 200, we take 204, 58 and 25, 16. So if we plot speed versus distance, right, it would be an inversely proportional graph, right? Which means as time increases, the speed decreases, right? For 32 it has to be 12.5 and so on. So this is a inverse proportional graph. Again, there can be a steep slope or not so steep slope, right? So again, the rate of change can be steep, so this is a steeper graph, this is not so steeper graph, right? So you have to see that if you are taking two values on a steeper graph, the difference would be huge. So if you take this and this, so the difference would be how much? Difference would be this minus this, so this minus this. And on not so steeper graph, the difference would be this minus this, right? So this small thing. So this would be the difference in second case, and this would be the difference in first case. So that's what the magnitude of increase or decrease means, or slope of the graph means. Though we are not bothered about the technical word slope, still we are bothered about the rate of increase or rate of decrease, right? And we would use them in lots of examples while solving the questions on line graph, right? So this is our first type of graphs. I hope that you are now well acquainted with various types of line graphs, right? The various slopes and all that stuff we have talked about, and you would be able to recognize what is what, right? How to plot a simple graph of proportionality. That's the takeaway from this lecture. I'm sure if you have to plot a v versus t, a velocity versus time, a distance versus time, you would be able to do that. And even if you have to identify one, you would be able to do that, right? So this is all about this lecture. We would study few questions in our next lecture. We would also do other various graphs like bar graph and pie charts and all that stuff in coming few lectures. So thanks for watching this video, and all the best for your preparations.